Go.
Hi, Izzy!
Feel better! I hope you feel better, Izzy.
How
do you feel, Izzy?
I have some cough drops for you.
Okay. Chapter 6, Lesson 3, Solving Systems Using Elimination. The first method was solving systems by graphing. The second method, solving systems by substitution. And now you have solving systems by adding, by elimination, pardon me. Okay, that screen shade's not working. So let's look at these two equations. 5x plus minus 6y equals negative 32, and 3x plus 6y equals 48. Now remember, when you are eliminating something, there are two variables here, correct? So your goal is to eliminate one of the variables so you can solve for the other one, and once you have the value of that variable, then you can plug in that value in one of the equations and solve for the other variable. If it doesn't make sense, you will get it once we go through this. Okay, so now look at these two equations, and I want to think about getting rid of one of the variables. Yeah?
So it's negative 6y and positive 6y.
And positive 6y.
Do they have
What
to
operation, pardon me?
Do they have to be, does one have to be negative and one have to be positive?
You tell me.
I don't know. Well,
Now remember when we did inverse operations, when we were solving single step equations, if you had x plus 5 equals 3, how did you get rid of the 5? Minus.
so they do have to be.
Ideally, we want it to be like that. You will come across examples where they are not opposite signs, and then you have to do something else to do that, to take care of that. So in this case, if I add 6y to negative 6y, those two will cancel, which means I'm going to add both these equations, every single term in these equations. Of course, you know that I can only add or subtract like terms, correct? Yeah. Okay, so I'm going to take this and I'm going to cancel these two.
And you could
Correct?
have canceled the. Oh no.
Right? Now remember, I'm adding these two equations. So if I added 5x plus 3x, you're going to get 8x. It's not going to cancel out. Okay, so I've canceled out the white terms. Now I have 8x equals 16. Divide both sides by 8, and I have x equals 2. Now I need to find the value of y. Now remember, I'm going to ask the same question I asked you at the beginning of the previous lesson, 6-2. What does the solution of an equation mean when you have a system of equations? It's the point at which both those lines intersect. So you need a coordinate, right? You need an ordered pair. So I have one value, I have the value of x. Now I'm going to use that value to find the value of y. Now,
it would be 2 comma whatever y is.
yes.
It's kind of like in the direct variation when we have those problems.
Exactly. Okay. Now, I can use either of these equations. Yes, Kristen?
Where did you get 16 from?
Where do I get
16.
16? Negative 32 plus 48.
Okay, so you're adding them.
Yeah.
So you're just kind of smushing them to eliminate?
You're combining them.
Yeah.
So
Okay.
and you add them.
At this point, I'm adding because that's the only way I can cancel these two terms, correct?
Yeah.
Can I cancel these two terms if I was subtracting those two terms? Exactly. So here's the hint. If you have opposite signs, you can just add. If you have the same signs, then you have to subtract. Okay? So negative 32 plus 48 gave me 16. Simplified it or solved for x, and I have x equals 2. Now I'm going to plug this value in one of these two equations. Do you have a preference?
The bottom one.
The bottom one, why?
Because it's easier.
There are no addition, there are no subtraction signs, there is no negative sign, so you can take care of, you can easily take care of it, right? Oh, there we go. Substitute x equals 2 in equation 2, which will give me 3 times 2 plus 6y equals 48.
Why does everyone like addition?
6 plus 6y equals 48. Subtract 6 from both sides. 6y equals 42. Yeah, y equals 7. So your solution is 2 comma 7. Yes, Zoe.
And when you eliminate, you don't do anything to the things on the right side of the equal sign?
You just add them.
Okay. So when you eliminate, you're just wiping them out. You're not adding them to anything. You're just taking.
You're just adding like terms in both equations. Okay?
It's like a gigantic addition.
Okay, here's an example. We have to do something to one of the equations so you're able to eliminate one of them. Okay? 2x plus 5y equals negative 22. 10x plus 3y equals 22. Now, at this point, can you eliminate any of the terms here, any of the variable terms?
Not right now.
No,
Well, you could.
Not by using addition.
Not in one step.
not in one step,
Yeah.
right? At this point, it's not ready to
If you want to do
go through that process, all right? But there's something you can do to modify one of the equations so you can get it to a point where it's ready to go through that process. Okay? Now keep in mind the equation that we looked at on the previous page. The term that we cancelled had the same variable term, had the same coefficient, and had opposite signs. Okay? Now, do you have anything here? Well, there are the x term and the x terms and the y terms. But which one can you cancel?
Oh, you could, couldn't you multiply the top one all by 5?
Can I multiply the first equation by 5?
And then you have,
Oh, and then you have 10.
Okay, let's do that.
or you could do
Hypothetically, let's take it step by step. I know what you were
Could you
saying.
multiply both equations to get 15?
You can do that. All right, which means you're trying to eliminate the y term, right?
Yeah.
What Michael is saying is, let's get rid of the x term, and you don't have to do both. You can just do one. Do you see that?
Yeah.
Yeah.
I'm confused.
What are you confused about? Tell me.
How do you just find out what to multiply by?
Okay, so you want the same coefficient, correct?
Yeah.
Either for the x or for the y.
Oh, it's
So Livia is saying, all right, this is 5y, that's 3y. If I multiply this equation by 3, this will become 15. If I multiply the second equation by 5, see, this is where I don't know.
It just feels like adding fractions, so you have to make the denominator.
Correct, yeah, exactly. All right? So she says, let's multiply that by, all that by 3, and you get 15. Or you can multiply all of that by 5 to get 15. But you have to do both, because if you try and change that equation by multiplying everything by 3, you'll get 6x plus 15y equals something, and then you'll have 50x plus 15y equals 22.
Wouldn't it just be easier to do the top one by 5 and then not change the bottom one?
If you do the top one by 5, you'll get 15, but you don't have a
No, the top one. If you
by 5. Oh
multiply
yes, okay, that's what Michael was saying.
the- Okay.
And then Father,
No,
yeah,
that's
I
what
said-
Michael was saying. Correct.
But wouldn't it be easier to just do the x, to
just do the y because then you just have, you can just.
It doesn't matter, actually.
It doesn't matter,
Yeah.
'cause you can plug in the x or the y. But Father, do
Yes.
you have to make it -5 or can you subtract?
Okay, that's the next question. So Michael said, let's multiply everything by 5. So you have to start seeing things in your head a little bit at this point. Okay, even you don't even have to write things down. You will have to, but even without going through that step, you have to kind of see what's going to happen if you did something to one of the equations. So Michael says, let's multiply everything. I know you changed what you wanted to do, but let's start with what you had in mind initially. So he says, multiply that by 5, that by 5, and that by 5. Okay? Great idea. What happens? I have 10x plus 25y equals 110. But is it at a place where I can cancel?
No, don't you want it to be
Well,
negative
can you
5?
subtract?
I want it to be -5. Remember, we wanted the same variable term with the same coefficient but opposite signs.
But you could subtract.
What is it? I could subtract, but we haven't done that yet. You know, when we learn subtraction, you can do that. Okay? So, you're going to multiply the entire equation by -5. If I do that, I get -10x minus 25y equals 110. Okay? So that's my third equation. So I'm going to bring the second equation down below. And now I have -10x, positive 10x. When I add those two, they cancel out, leaving me with -25y plus positive 3y equals -22y equals 132. Divide both sides by -22, and I get y equals -6.
Father, you can subtract.
What is that? You can subtract. But since we haven't talked about subtraction, I'm not going to get into that. It's the same thing, yeah. Then I'm going to take y equals 6 and plug it in one of the equations. Which equation should I use here?
Second.
There's actually 1, 2, and 3.
Oh.
Aren't you better off doing
First.
I like doing it the first.
The first.
the first?
'Cause it's
Okay,
smaller.
let's see what I've done. Yeah, let's do that because smaller coefficients, right? So 2 times -6 is -12 plus 5y equals -22.
No, it's 2x plus 5 times -6. It's because that's the y coordinate.
Oh, pardon me. You're right. 2x plus 5 times -6 equals -22. 2x minus 30 equals -22. Add 30 to both sides. I get 2x equals 8. X equals 4. And my solution is 4 comma -6. Alright? So the first example was a system where it was ready to go through the process of elimination. The second example, you have to change one equation to make it work. Let's see what we have.
Is there problems that you have to change both equations?
You think that's the next one?
It's like you read my mind, Lucy.
It's like fraction.
All right, so take a good look at those equations.
Wow, it's so big.
4x plus 5y equals 15. 6x minus 4y equals 11. Can I just change one equation
No.
and go through the process of elimination? 4 doesn't,
You can't
unless
do fractions.
you're doing multiplying by fractions. I don't know if you want to do that.
1/4.
You could, if you're adventurous, you can do that. So for now, we're not going to consider that option. So 4 is not going to turn to 6 or 6 to 4, 5 to -4 or 4 -4 to 5. Jack?
What if we multiply the first equation by 3 and the second by 2?
If I multiply the first equation by 3,
Yeah, 4x becomes
Then you get
12x and 6x becomes 12x.
But Father, that's going to be harder.
How?
okay. Now is that, can you do that?
Yes.
No,
Yeah.
but Father, they're not going to be the same. No.
Yeah, they will.
Yeah.
Yeah,
No,
No, you
what
mean
I'm
John? Do you mean the sign?
Yeah, the sign.
Okay, so you
One
just,
of them you have to do that.
the negative, right? Okay.
You would do -3 and then.
Or,
Or
or you can multiply this by 4 to get, see, and I say, Izzy should know what I'm talking about. Alright? So I multiply that by 4. Now, of course, I'm not multiplying only that by 4, I'm multiplying all the terms by 4, right?
And you
And I multiply,
by 5?
how do I get different colors? And then I'm going to multiply this by 5, that by 5, and that by 5. Now, what is the advantage of doing the y term here? Yeah?
You don't have to, you're multiplying by both positives.
I'm multiplying by a positive term, right? Because this is plus and that is minus. You can take care of, you can do that to the x term, but remember, if you're multiplying this by 3, then you have to multiply the second term by -2, so it cancels out. Okay? Let's see what I've done here. Multiply 1 by 4. Okay, so we are trying to eliminate the y term. And I have 16x plus 20y equals 60. And I'm going to multiply the second equation by 5. And I get 30x minus 20y equals 55. Okay? 20y and -20y cancel out. And I have 16x plus 30x equals 115. Correct?
Yes.
Right? So divide both sides by 46. And I get x equals 2.5. What is the next step?
Substitute.
Yes. Substitute x equals 2.5 in equation 1. And you have 4 times 2.5 plus 5y equals 15. Simplify, solve for y, and you have y equals 1. So your solution is 2.5 comma 1. Are we good so far? Sure?
Father, could you do this with 3? If you had 3 problems?
3 equations?
3 equations?
Yeah, you can do that. So this is what Jack was talking about. So I can eliminate the x term by multiplying by -3, the first equation by -3, and the second equation by 2, or I can do the first equation by 3 and the second equation by -2, correct? And then you eliminate the x term, solve for y, I get 1, and plug that in the equation, and I have x equals 2.5. Now in terms of arriving at the answer quicker, this seems faster, doesn't it? Because in the other equation we had something like 115 divided by 46. And I don't know if you want to go through that, not that you can't, but here 10 divided by 4 seems much easier to simplify than 115 over 46. Okay. How can we forget fractions? I know. 2/3 x minus y equals 70. 1/3 x minus 2/3 y equals 43. What are some of your options?
Multiply the second
Jimmy?
Multiply the second equation by negative.
Can't look at your notes.
I don't know. Wait. Yeah, negative 2. Whoa. Yeah. Well, negative. Yeah, it's negative 2 because. It's 4. Yeah. Because 1/3 times 2.
Let Jimmy speak.
Okay, so you would do negative 2 because 1/3 times 2 is 2/3. So, yeah, it's 2.
Multiply by 2.
Negative 2.
Multiply the second equation by negative 2. So if I do that, I get negative 2/3 x plus 4/3 y equals negative 86. Okay, that's an option.
Why would you do it?
Zoe?
Can you multiply it by 3 or negative 3 so you can have whole numbers?
I would do that.
But you didn't do it in the note.
I didn't do it in the notes. That's okay. I can't. What method did I use?
Do 2.
Okay. Now, why can't I?
Why would you multiply by a whole number though? I would multiply to get a whole number.
Yeah, but isn't that easy? Like, remember when we talked about multi-step equations in 7th grade? You can find the LCD of a number and multiply every single term by that number, and that way you're not dealing with.
This is easy.
No, but they were saying like, why can't you multiply by 3 to cancel it out, and then you get like 1.
Correct. Yeah.
That's what
But then you can't get the you can't cancel it out when you multiply.
Well, that's what I want to see.
You have 3y. So.
Father.
Well, you
Okay.
have 3y.
What we'll do is we'll stop here.